Relative change. Another type of change that we can consider in calculus to study how different functions change is something called relative change. Consider this. If you received a dollar discount on some product, was that deduction a significant change? Well, the answer is that it really depends on what you bought. So consider the first scenario. You're buying a car that's listed as $25,000 on the lot. When you go in to talk to the dealership, they offer to sell it to you for $24,999. Scenario 2. You always stop to buy a medium iced coffee at Dunkin' Donuts for $2.64. Today they're running a promotion that all medium iced coffees cost $1.64. Now, in both of these scenarios, you received a $1 discount. However, one of them feels better than the other, as in it feels more significant. And the question is why? And the reason is relative change. Because for both of these products, we're saving $1, but that dollar is relative to the amount that the product costs. So we're going to explore how we can use relative change to look at various scenarios and talk about what it means in terms of the products and items that we are considering. Relative change, also sometimes referred to as percent change, is a mathematical way to compare two quantities while taking into account the size of the numbers being compared. So what that means is we're going to be looking at how much our price changes, but we're going to use a way to compare that with what the original price of the item was. So the way we write this formula mathematically is P1 minus P0 divided by P0. So let's talk about what these different things represent. P sub 1 is the new price that you're getting, either because the price has gone up or because the price has gone down. P0, which is the same thing as P sub 0, so P with the subscript of 0, is the original price that we're using as the basis to compare how much it's changed. Now, the top part, P sub 1 minus P sub 0, is called the absolute change. So if you're looking for the difference between two quantities, you would subtract them, and that's called the absolute change. But by dividing by the original number that we had, we're finding the relative change. So here, like I mentioned, in the scenarios we'll look at, there's going to be a change in price. We're going to reflect that in the numerator, and we're going to divide by the original price. It's important to note that the relative change is going to be a number without any units, and we often turn our result into a percentage, which means a lot of our results are going to be decimal numbers. So let's go ahead and look at a couple of scenarios where we can actually calculate this relative change using this formula P sub 1 minus P sub 0 divided by P sub 0. Example 1. Calculate the relative change for the scenarios presented above. Scenario 1 was that we were buying a car for $25,000 and the dealership offered to sell it to us for $24,999. So here, the original price was the $25,000. So in this case, that's our P sub 0, the original price. $24,999 is our new price that we're going to be getting if we decide to buy this car. So to find the relative change, we need to use the formula P sub 1 minus P sub 0 divided by P sub 0. So plugging in the numbers from our scenario, we get 24,999 minus 25,000, all divided by 25,000. It's important to remember which numbers go where, and that order is important. So here, when we carefully plug all of these things into our calculator, we're going to get negative 0.00004. It's a lot of zeros. So if we want to calculate that as a percentage, we would multiply that number by 100 to turn it into a percentage. So this is equal to 0.004% decrease. So it's a 0.004% decrease in price. So I'm using the word decrease to replace the negative. So I'm using the word to replace the symbol, but these mean the same thing. Now let's consider the second scenario. So our iced coffee that's normally $2.64, so that's our original price, today has a promotion where we're going to get it for $1.64. So that's my new price. So again, applying my formula, I'm going to do piece of 1, which is $1.64, minus P naught, $2.64, all divided by the original amount, $2.64. So again, I'm going to put this into my calculator. Turns out when I put it into my calculator, I get a lot of decimals, unlike the previous problem where I just terminated at 4. There were no other numbers after it. So here, what I need to do is I need to use the approximation symbol because I'm going to do some rounding. So here, I'm going to call this negative 0.3788. If I were to turn that into a percentage, which I'm usually going to do in this type of problem, I would multiply by 100 and I would get this is approximately a 37.88% decrease in price. So again, I'm replacing my negative with the word decrease because when we talk about percentages, we don't usually use a negative sign with percentages. Instead, we use a word afterwards to indicate whether that number was positive or negative. So here you can see there's a very large difference in the discount we're getting in scenario 1 and scenario 2. In scenario 2, the discount is much larger, 37% approximately, compared to your 0.004%, which feels like nothing. So your gut reaction that scenario 2 you got a better deal is probably right when you think about the relative change. So again, when we have a negative, we're going to use the word decrease. If we had had a positive number, we would use the word increase at the end. Generally, we're going to put either increase or decrease at the end of our percentage to indicate what was happening. If there's no word present, then increase is implied. So if we had put 37.88% with no word and no negative, it would have been implied that it was an increase and would have been incorrect. So we need to make sure that we're using words to represent what's happening mathematically. Example 2. Find the relative change for each of the following scenarios if price increases by $4. So here we're going to have to do a little extra work to find our piece of 1. So scenario 1. There's a gallon of milk that costs $4. For this scenario, we're considering what would happen if the price increased by $4. So the original price was $4, and if we increase by $4, that means that our new price, our piece of 1, is going to be $8 because we add that 4 to the original cost. So now, when we plug this into our formula, piece of 1 minus piece of 0 divided by piece of 0, we're going to get $8, the new price, minus $4, the original price, divided by the original price of $4. And 8 minus 4 is 4, divided by 4 gives us 1. So we usually have decimal numbers, but we don't have to. We still want to turn this into a percentage by multiplying by 100, and that's going to give me a 100% increase in price here. So that feels like a lot. If we were normally used to paying $4 and now we're paying $8, the price is increased by 100%. Scenario 2. A Chromebook computer costs $150. So that's the original price, P0, $150. Since we're considering what happens if price increases by $4, that means our P1 is $154 because we take our original price and we add that $4. So now, if we plug that into our formula, we get $154 minus $150, all divided by $150. So again, we're going to carefully crunch that number. We can simplify it first if we want to 4 over 150. And when we plug this into the calculator, we're going to get another long decimal. Since we're going to be rounding, I'm going to change this to approximate. And we're going to get 0.0267. And and I'm cutting it off at 4 decimals. Here, if we turn this into a percentage increase, we're going to multiply by 100, and we're going to get 2.67% increase in price. So that feels less shocking. So a computer that's gone from $150 to $154 has a 2.67% increase, whereas a gallon of milk that went from $4 to $8 had a 100% increase. Example 3. Suppose that when a store sells a particular necklace for $60, they sell 65 per week. When they have their annual store sale, they reduce the price by 25%, and during that week, they sell 110 necklaces. Find the relative change in weekly sales. Now, this word problem is really interesting because there's a lot of information here, and we need to be really careful about what information we need and what's extraneous information. So let's go back to the question. Find the relative change, that's what we've been looking at, relative change, in weekly sales. So what we're comparing here are weekly sales. So the two numbers we have for weekly sales are the 65 necklaces per week at the regular price and 110 necklaces per week at the sale price. Those are the two numbers that we're going to need to find our relative change. In this scenario, the $60 and the 25% aren't giving us the information we need to find the relative change in weekly sales, so those are extraneous numbers. So I encourage you, when you're doing word problems, to make sure you understand the question and to underline what you think is the relevant information. So here, since we typically sell for $60, that means that the 65 necklaces per week is our original amount, because that's the amount we typically have and that we're comparing to. 110 necklaces is the new amount that comes with our sale. So when we plug this into our formula, we have P sub 1 minus P sub 0 over P sub 0. We're going to plug these numbers in just like we've been doing. We have 110 minus 65 divided by 65. So again, we're going to go to our calculator for this. And again, we're going to get a decimal number. So I'm going to turn this to approximately. And when we crunch these numbers, I get 0.6923. So again, I'm going to multiply my decimal number by 100 to get the corresponding percentage. And I get 69.23% increase. So I know this is an increase because it was a positive number. The 110 minus 65 gave me a positive outcome. Therefore, I'm using the word increase. So the number of necklaces that I sell increased by 69% approximately. That's pretty good. This problem also hints at something else that's pretty important. So here we're talking about what kind of increase we have in sales for a decrease in price. As you can imagine, this is something that economists and people in various businesses like to study to learn about how their discounts impact their sales. Turns out there's a specific calculation related to relative change that we can look at that's going to help inform decisions about sale prices and products. If we look at the ratio of relative changes, also known in economics as elasticity, we can look at the relationship between a change in price and the change in demand of a quantity. So elasticity is the percentage change in the quantity demanded that results from given percentage change in the price. So when we calculate elasticity, we're going to be getting a factor that we'll use to inform us about whether or not our discount is relevant and something we should continue doing, or if our price increase is something that will impact our consumer base. Specifically, elasticity is the ratio of the two related percentage changes. It is the percentage change in quantity, so that's what we looked at in the last problem with the necklaces, the change in how much we sold, divided by the percentage change in price. So we didn't look at that in the last problem, but we will in the next. We can find the change in price and also reflect that as a percentage. This ratio of the percentage change in quantity divided by the percentage change in price is always going to be expressed as an absolute value. So this number is the elasticity, and it's a factor that we use to make decisions in businesses. So let's look at a problem and see how we apply this. So let's go back to our necklace example. We know that this particular necklace sells for $60 and they sell 65 per week. When they have their sale, they reduce the price by 25%, and during that week they sell 110 necklaces. We want to find the elasticity of this particular necklace based on its sales. In the last problem, we were able to look at the relative change in weekly sales. So the relative change in weekly sales is the relative change of the quantity. And we found that to be approximately 69.23%. In order to talk about the elasticity, we need not only the relative change of the product, of the number of products, but also the relative change of the price. Now here, you may have some intuition that this 25% is really important. And it is. It turns out that that is the relative change of the price. But we can calculate that out just to be sure. So if we have a 25% discount, if we were to multiply 60 by 25%, 0.25, that would give me the number 15. And what that represents is the amount of money that I'm going to take off of the price for this sale. So normally, the necklace is going to cost $60. I'm multiplying that by 25% to see how much of a discount I get, which is $15, which means that my new price is going to be 60 minus 15, which gives me $45. So my new price is $45. My original price was $60, and I can use that to calculate the relative change. So 45 minus 60 divided by 60 is going to give me negative 0.25, or a 25% decrease in price. So again, here when we say we reduce the price by a certain percentage, that's the same thing as the relative change. So we're going to take these two numbers, the relative change of the product number and the relative change of the price, and we are going to look at the ratio of these two numbers to tell us the elasticity. To find the elasticity, we need to look at the ratio in a very specific way. It's going to have the change in the number of products on top, or the change in quantity, divided by the relative change in price. So here we have 69.23% divided by 25%. And technically this is a negative 25%, but since we have to take the absolute value at the end, we don't need to include that. Now, because 69.23% was rounded, any calculation that I use with this number is going to be approximated. So I'm going to use my approximation sign. When I divide these, I'm going to get When I divide these, I'm going to get 2.7692. Now, that number may not have a lot of meaning for you depending on what your major is, but elasticity is usually compared to the number 1, with numbers higher than 1 being a good idea, and numbers lower than 1 needing to have more consideration. Of course, it depends on the industry and product you're looking at, but here, this may encourage our particular retailer to put this necklace on sale more than one time a year. Let's take a look at one more example where we need to work out all the parts to find the elasticity of a product. So example 4. Suppose the cost of a pound of high-end local ground coffee is normally $19.99. At this price, 275 pounds are sold each month. When the coffee goes on sale for $14.99 during the month of April, 425 pounds are sold. We need to find the relative change in price, the relative change in monthly sales between the typical month and the sale month, and the elasticity of this product. The first two calculations will give us the numbers we need to find the elasticity. So let's start by finding the relative change in price. Again, we need to be careful and make sure we're using the right information. So if we're looking for prices, we're looking for dollar amounts. The two dollar amounts given to us are $19.99 and $14.99. Since it says the coffee is normally $19.99, that particular number is going to be our P naught. The new price is the price that we have when it goes on sale. And so that price is going to be our $14.99. Putting those together in our formula, we get $14.99 P1 minus $19.99 P naught divided by $19.99 or P naught. So here again, we're going to very carefully crunch that number in our calculator. And when we plug that all in, we are going to get approximately, I'm going to round this, negative 0.25. So negative 0.25, if we multiply that by 100, is going to give us a 25% decrease. Now, the next part, now that we have our relative change in price, is to find the relative change in monthly sales. So remember, when we typically sold it for $19.99, we were able to sell 275 pounds of coffee. When we changed the price to $14.99, we were able to sell 425 pounds. Since the typical amount is 275, that's our P naught, which means that our new quantity here, our new P, is going to be 425. That's our P1. So now, to find the relative change in sales, or the relative change in quantity here, we're going to use our formula. We're going to do 425 minus 275, all divided by 275. So again, we're going to crunch that in our calculator. I'm going to round, so I'm going to use the approximation symbol. So I have 0.545, or 54.5% increase. So this is good, right? We're hoping that if we lower the price, that people will buy more. And that's what's happening here. If we decrease the price, the percentage that we sell goes up. So this seems so far like a pretty good business model. But to know for sure how much it impacts people, we're going to go ahead and calculate the elasticity. So again, the elasticity, I'm going to write this as E, is approximately 54.5, the relative change in quantity, divided by negative 25. And again, the negative doesn't really matter because we're going to take the absolute value of our answer, but it is there since it was a decrease. We get negative 2.18. And again, that's approximately. And if we take the absolute value of that, our factor is 2.18. And again, businesses often want elasticity to be greater than 1 because they found that if elasticity is less than 1, people don't react very much to the sale or to the price impact. So we're looking for something bigger than 1 to get people out to buy the coffee.